Astronomers have long observed that our galaxy, the Milky Way, is not alone in the vast expanse of the cosmos. It is part of a larger cosmic neighborhood, teeming with other galaxies, stars, and celestial phenomena. This neighborhood is known as the local group, a collection of more than 50 galaxies bound together by gravity. We are part of a gathering of galaxies known as the local group. This group includes not only the Milky Way, but also the Andromeda Galaxy, the Triangulum Galaxy, and numerous smaller dwarf galaxies. Each of these galaxies has its own unique characteristics and history, contributing to the rich tapestry of the universe. Among them, the Andromeda Galaxy stands out as our largest galactic neighbor. It is a spiral galaxy much like our own, but significantly larger, containing roughly 1 trillion stars compared to the Milky Way's estimated 400 billion. Andromeda's sheer size and proximity make it a subject of great interest and study. What's even more fascinating is that Andromeda is not just a distant neighbor, it's on a collision course with our own Milky Way. This impending collision is driven by the gravitational forces that govern the motion of galaxies. Over time, these forces are drawing Andromeda and the Milky Way closer together. This isn't a cause for alarm though. The universe works on timescales far grander than we can easily comprehend. The collision won't happen for billions of years, giving us plenty of time to study and understand the processes involved. In fact, such events are a natural part of the life cycle of galaxies. The collision won't happen for billions of years. When it does occur, it will be a slow, drawn-out process, taking place over millions of years. During this time, the two galaxies will pass through each other multiple times, their stars and gas clouds interacting in complex ways. However, the evidence is clear. Observations of Andromeda's movement, combined with our understanding of gravity, confirm that these two galactic giants are destined for a spectacular merger. This conclusion is based on precise measurements of Andromeda's velocity and direction, which show it heading straight for the Milky Way. Observations of Andromeda's movement, combined with our understanding of gravity, confirm that these two galactic giants are destined for a spectacular merger. The gravitational forces at play will reshape both galaxies, creating a new, larger galaxy in the process. This new galaxy will be a blend of the Milky Way and Andromeda with characteristics of both. This impending collision is a natural part of galactic evolution. Galaxies are dynamic entities, constantly changing and evolving over time. Collisions and mergers are one of the ways in which galaxies grow and develop, leading to the formation of new structures and the redistribution of stars and gas. Galaxies, much like stars, are not static entities frozen in time. They interact, collide, and merge, shaping and reshaping the universe around them. These interactions can trigger bursts of star formation, create new star clusters, and even lead to the formation of new galaxies. They interact, collide, and merge, shaping and reshaping the universe around them. The coming together of the Milky Way and Andromeda will be a slow, drawn-out dance lasting billions of years. During this time, the two galaxies will exchange stars and gas, creating new patterns and structures. The coming together of the Milky Way and Andromeda will be a slow, drawn-out dance lasting billions of years. This cosmic ballet will result in the formation of a new galaxy, often referred to as Milkomeda or Milkdromeda. This new galaxy will be larger and more massive than either of its predecessors. It will forever alter the cosmic landscape we call home. The night sky will look very different with new constellations and patterns of stars. This grand event is a reminder of the ever-changing nature of the universe and our place within it. To understand the upcoming collision between the Milky Way and Andromeda, we must first familiarize ourselves with our galactic neighborhood, the local group. This vast collection of galaxies is our cosmic home, a gravitationally bound cluster that offers a glimpse into the larger structure of the universe. This collection of over 50 galaxies, bound together by gravity, spans a region of space roughly 10 million light-years across. Within this immense expanse, galaxies of various sizes and types coexist, each contributing to the intricate tapestry of the local group. At the heart of the local group lie its two most massive members, the Milky Way and Andromeda, spiral galaxies each containing hundreds of billions of stars. These colossal structures are not just collections of stars, but also vast reservoirs of gas, dust, and dark matter, all interacting in a complex gravitational ballet. These gravitational giants dominate the local group, influencing the motions of their smaller galactic companions. The gravitational pull of the Milky Way and Andromeda extends far beyond their visible edges, shaping the orbits and paths of numerous smaller galaxies. The remaining galaxies in the local group are mostly dwarf galaxies, much smaller and fainter than their larger counterparts. These diminutive galaxies, though less prominent, play a crucial role in the dynamics of the local group, often serving as cosmic laboratories for studying galaxy formation and evolution. These dwarf galaxies, like satellites orbiting a planet, are often found in orbit around the Milky Way and Andromeda. Their interactions with their larger neighbors can lead to fascinating phenomena, such as tidal streams and galactic cannibalism, where larger galaxies absorb their smaller companions. The local group is a dynamic environment. The galaxies within it are not static. They are in constant motion, influenced by the gravitational forces exerted by their neighbors. This ceaseless movement creates a complex and ever-changing cosmic dance. The galaxies within it, while separated by vast distances, are constantly moving under the influence of each other's gravity. This gravitational interplay can lead to close encounters, where galaxies pass near each other, and even to collisions and mergers. This intricate gravitational dance ultimately leads to galactic interactions and mergers, shaping the evolution of the local group over cosmic timescales. These interactions are not just random events, they are fundamental processes that drive the growth and transformation of galaxies, influencing their structure, star formation rates, and overall evolution. We know that the universe is expanding, driving galaxies apart from one another. So, how is it possible for galaxies to collide when the very fabric of space is stretching? The answer lies in the power of gravity. While it's true that on a grand scale the universe is expanding, this expansion is not uniform. Gravity still holds sway on smaller scales, like within galaxy clusters and groups. The gravitational attraction between galaxies in close proximity, such as the Milky Way and Andromeda, can overcome the expansion of space, drawing them closer together over time. Think of it like two boats floating on a river. Even if the current is carrying them downstream, if the boats are tied together with a rope, the tension in the rope will eventually pull them towards each other. Similarly, the Milky Way and Andromeda are bound by the invisible rope of their mutual gravitational attraction. This force overwhelms the expansion of space between them, setting the stage for their eventual merger. The impending collision between the Milky Way and Andromeda may seem like a distant event, but we can catch glimpses of what's to come by observing other colliding galaxies in the universe. These cosmic events are not just theoretical. They are happening right now in various parts of the cosmos, providing us with a window into the future of our own galaxy. One such example, the antennae galaxies, offers a captivating preview of the dramatic events that unfold when galaxies collide. These galaxies are among the most well-studied examples of galactic collisions, thanks to their relatively close proximity and the spectacular show they put on. Located about 70 million light-years away, the antennae galaxies are a pair of spiral galaxies caught in the throes of a cosmic collision. This distance, while vast, is close enough for astronomers to study in great detail using powerful telescopes like the Hubble Space Telescope. Their name comes from the two long, antennae-like tails of stars and gas extending outward from the colliding galaxies, a result of the immense gravitational forces at play. These tails are formed as the galaxy's gravitational fields interact, pulling stars and gas out into space. Observations of the antennae galaxies reveal a chaotic yet beautiful scene. The collision has triggered a burst of star formation, lighting up the galaxies with new young stars. This chaotic environment is a testament to the dynamic and ever-changing nature of the universe. Clouds of gas and dust, compressed by the collision, are actively forming new generations of stars. These regions, known as starburst regions, are some of the most active star-forming areas in the universe, producing stars at a rate much higher than in more quiescent galaxies. The galaxy's spiral arms, once graceful structures, are distorted and disrupted by the gravitational tug-of-war. This interaction not only distorts the shapes of the galaxies but also mixes their contents, leading to new patterns of star formation and galactic structure. The antennae galaxies serve as a reminder that galactic collisions, while destructive on one hand, also act as engines of creation, giving birth to new stars and shaping the evolution of galaxies over cosmic time. These events highlight the dual nature of cosmic collisions. They are both destructive and creative, tearing apart existing structures while simultaneously fostering the birth of new ones. This ongoing process of destruction and creation is a fundamental aspect of the universe, driving the evolution of galaxies and the formation of new celestial bodies.